This chapter is going to focus on water, both water on the surface that we know as rivers and streams, and water underneath the surface, which is known as groundwater. But we're going to start off with this video talking about river systems. And when we're talking about water on our planet, most of the water along our surface is coming from precipitation. And after we have some form of precipitation, whether it's rain or snow, some of that water is going to be able to soak into the ground. And this is called infiltration, because the water is breaking into or infiltrating into the ground. But the ground can only hold so much water. So while some of the water will infiltrate into the ground, a lot of water will also be known as runoff. It's going to flow along the surface. If you've ever been stuck on I-4 during a massive rainstorm, you've probably seen the streams of water that flow down the concrete. This is runoff. It's water that hasn't been absorbed by the ground. So we're going to see that the amount of runoff is going to depend on the amount of precipitation. And a lot of different things are going to affect this, like the intensity and the duration of the rainstorm. The longer and the harder that it rains, the more water and therefore the more runoff. But we also see that the amount of water that's already in the soil is also going to be important because, again, the soil can only hold so much water. So if it's already holding the maximum amount it can hold and it rains, it won't be able to absorb any of that water. All of it will be runoff. And we also have to look at the nature of the surface material and the slope. So think about surface materials, whether it's grass or concrete. In a major city, the water is not going to be able to infiltrate into the ground because of the concrete. Instead, it's going to form more runoff. But if we were in a field full of corn in Kansas, because it's dirt, it's going to be able to infiltrate and we will have less runoff. The slope is also important because the steeper the slope is, the more quickly the water will run down the side and it won't have time to infiltrate. And then finally, having vegetation, some kind of plant life, will absorb some of the water, allowing the ground to absorb more. But before we get into streams, we need to talk about drainage basins. And a drainage basin is the entire area where a single raindrop in that area will eventually make its way out through a river. But one of the things I want to point out on this image is that within a drainage basin, we have multiple smaller rivers that are eventually going to join together and form the larger river that flows out into the outlet, where it's going to discharge all of this water into an ocean. We also have multiple scales of drainage basins. They can be relatively small if we're talking about a local stream, or they could be half the size of the country if we're looking at the drainage basin that makes up the Mississippi River. If we look closely, there are multiple smaller, even though they're still very large rivers, like the Missouri River and the Ohio River, that will join together and form the Mississippi. But this entire drainage area, any drop of rain that falls within this area, will eventually be discharged through the Mississippi River off the coast of Louisiana. Most rivers follow a very specific pattern. They're going to start off in a mountainous region, which is called the headwaters. And rivers will end in what's called the mouth, in a really flat coastal region. Think of like a beachy coastal area. But in different areas of our stream, the water is going to be doing different things, depending on how fast the water is moving and what kind of sediments make up the bottom of the stream. So if we look at the headwater region, the mountainous area where the stream first forms, we're going to see that there's a lot of sediment production. Sediment is produced because of erosion and weathering. As the water moves very quickly over these steep slopes in the mountains, it's going to erode the sediment, producing sediment over time. It's dominated by erosion. But if we look in the middle of our stream, this area is known as the zone of transportation because it's transporting sediment from the headwaters down to the mouth. It's not eroding, it's not depositing, it's simply moving the sediment from a higher area to a lower area of the stream. And then the final part is where sediment is being deposited. Down by the mouth of the stream, the water is slowed down so much because it's a very flat area that it's going to start depositing all the sediment that it's been carrying through the zone of transportation. It's eventually going to form a delta inside of our oceans.